this is going to be very informative for everybody here. I was privileged to be in Windsor earlier this year in March to the Great Lakes Fishery Commission annual meetings. This year was the State of the Lake report for Lake Huron, and over 2 days there was presentations on just about every aspect of Lake Huron that you could want to know about, the latest up-to-date information. We are very lucky here tonight that we've got 2 biologists from the Ministry of Natural Resources, Dave Reed and Dave Gonder from the Upper Great Lakes Management Unit. And they are basically going to attempt to put 2 days of presentations into a 2-hour presentation here to bring you guys up to speed as to what is going on. I'm sure that you'll find it very informative. Without further ado, I'll turn it over to Dave and Dave.
Okay, well, we're going to tag team a bit. I'm going to start and give you a little bit of historic background. This stuff actually wasn't given at the Great Lakes Fishery Commission meetings, but I wasn't sure of the background of everybody in the audience, so a lot of this stuff is known by the biologists that have worked on the lake for many years, but if you're not familiar with it, it does lay the foundation for the later stuff that comes along. So I'm just going to give a quick walkthrough. So interestingly enough, Lake Huron was the first of the Great Lakes that was discovered and encountered by the European explorers. They actually went up the Ottawa River and came through the French River and came into Georgian Bay. So that's when they called it the Sweet Sea. And interestingly enough, we would have thought it was Lake Ontario, but it was Lake Huron. And the lake that they discovered and the fish that were in that lake, the ecosystem has undergone a lot of changes since that time. Historically, back in those days, this was a simplified version of what the ecosystem was like in the lake. It was dominated by lake trout. There was walleye, or yellow pickerel, as some people call them, in the nearshore area that were the main predator. There was burbot in the bottom part of the lake. They like to stay on the bottom. And there was a pretty diverse crayfish community that was supported by what we call a Cisco flock. There was all these different Ciscos out there that utilized different areas of the ecosystem and fed on different things and really filled out the entire ecosystem. As well, there was other prey fish species as well, Cisco and Sculpins. And as I mentioned, the flock was pretty diverse, but it became, most of it is extinct. These are gone, those are gone, those are gone. There's a little bit of the short jaw Cisco they found around Tobermory, but they're very remnant and they were probably on the way out themselves. The only one we got are the hoya out of that. As well, there was lots of lake trout out there, as I mentioned. We don't know exactly what strains were out there because they're all gone, although we know from talking to some of the commercial fishermen that were around at that time, reading their stories, there were a lot of different lake trout out there. They looked different and they probably occupied different areas of the lake. We know from Lake Superior, these are pictures from Lake Superior, that there's 3 main strains there in Lake Superior. They call them the leaves, the Siskoets, and the humpers. And they have different body fat. They feed on different things and they live in different parts of the lake. Siskoet are very deep. The humpers live on humps out in the lake. That's where they get their name from. And the leaves generally hug the shore. So historically, it was a system really driven by lipids or fat content. At the bottom, we had mysis and ponifraria, or diapria it's called now. And that really fed the system. It fed the Cisco flock, and they fed the lake trout. It was a very efficient system. The benthic mysis and diapria would come up at night and be fed on by the flock, and they'd be fed on by the lake trout. But things started changing in the 1800s and into the 1900s, and the first changes came with the creation of canals. So there was a number of canals that connected the upper lakes to the lower, and it basically got around Niagara Falls. So when they were created, it created a highway for new species to come in. smelt came in, the alewife, and the sea lamprey. So this is what we call the first wave of exotic species. And the sea lamprey really took a toll on the lake trout. They just about wiped them out. We have 2 remnant stocks in Lake Huron, in Iroquois Bay in the North Channel, and in Perry Sound. Other than that, they were completely wiped out. And the only other place in the Great Lakes that they remained were in Lake Superior. As well, there was commercial fishing that put pressure on the lake trout as well. So without a predator out there, when these exotics came in, they just exploded. The alewife were everywhere. You know, some of you people may remember in the 60s when they would die off in bad years because they were at the very range of their northern limit. When there was a bad cold winter, they would die off and litter the beaches. So the lake wasn't really good for very much. There was very few lake trout out there. There was nothing to eat these alewife and smelt at the time. And it really started changing around when the Great Lakes Fishery Commission was formed in 1955, and they discovered this chemical, TFM. I won't bother trying to read the chemical name for it, but in 1958 they went through many, many different chemicals trying to find something that could control the sea lamprey. They eventually found this TFM treatment, and that's when they started treating the lake in the early 1960s, and that opened the avenue that we could start stocking again because these fish would hopefully survive. And that's what happened. We started stocking lake trout again, and many of you in the audience are involved with clubs that started stocking Chinook and brown trout, rainbow trout. And that really took off. The Chinook were able to really chow down on the alewife, and they created a really good fishery, as many of you know. So the situation now is quite a bit different. There's a lot of non-native species out there. They're the ones I put in the red box. So the flock is just about gone. As I mentioned, the bloater chub left, and that's it from the flock. But the alewife and smelt are still out there, although David will talk next about the changes they've gone through. And we have the brown trout and rainbow trout that I mentioned, and Chinook salmon was a key player in this whole thing until the last decade or so when they declined. And the second wave of exotic species came along in the late 80s, early 90s. As the European ports started cleaning up their act, they started getting more species moving into these ports. And when these ships took on ballast water, they started taking a lot of these critters into their ballast water. And when they come across the Great Lakes, up the St. Lawrence Seaway, through the Welland Canal, they brought a lot of these new species. So now we're having to deal with zebra and question mussels, fish treffies, and fish hook, water fleas, etc. So this is the new wave, and some of these are having even more impacts and more changes on the ecosystem than even the sea lamprey in the first wave. So that's where I'm going to pass it off to Dave. So is there any questions about that little run through the history, or we'll jump into the Great Lakes Fishery Commission?
Just a comment there.
Yep.
You mentioned cormorants. I did see a red box around them because
Well,
historically they weren't here.
Well, there's
And then they
debate.
did.
There's debate about that, Dennis. I could have had, maybe I should have had a dotted red box. There's debate. They were in Ontario for sure, up in the Lake of the Woods area.
Yeah, not like your own.
Well, there's debate about that. Granted.
Okay.
Granted, they were sure never here in the numbers that they are now. That's for sure.
So, before I jump into the information from our recent State of the Lake conference, both Dave and Al gave a good preamble. I'll provide a bit more detail about how our GLFC business works. Ontario's signatory to the Commission. We have commissioners that sit on the Commission from Ontario. And the management agencies work cooperatively on each lake through a Lake Huron. On Lake Huron, it's the Lake Huron Committee that represents agencies with management authority. And I participate in the Lake Huron Technical Committee, which is field level biologists. Part of our business at the Commission is to develop and present State of the Lake reports on a 5-year rotation. This year was Lake Huron's turn. So this was the state of Lake Huron from 2005 to 2010. Our last State of the Lake Conference was issued in 2004. So it's an update as to what's been happening in the lake and our progress towards our fish community objectives, which are laid out in the Fish Community Objectives for Lake Huron document, again, a Great Lakes Fishery Commission document. So just to look back to our last State of the Lake report, this is the one we issued in 2004. Before I get too far along, I should also mention that, as Al discussed, what I'm going to present is a paraphrased version of 18 or 19 presentations that we gave over a 2-day period. So I'm only gleaned a couple to maybe 5 or 6 slides from each of those presentations. There's a lot of information here. There's fairly clear breaks between each presentation that I paraphrased, so there's probably opportunity for questions at the end of each little chunk, which represents one presentation that was issued in May. So this was fodder from the first talk. It's really just a recap of our last State of the Lake. So in 2004, we'd seen changes in the plankton community, increases in invasive zooplankton species. So those are part of the lower trophic levels in the lake. Plankton are major food fodder for prey fish and juvenile game fish species. We see a decline in abundance and distribution of diaperia, which Dave mentioned, very important link in moving energy in the open water portion of the food web. A major expansion of dracenids, aka zebra and quagga mussels, invasive mussel species. By 2004, we'd already observed the collapse of alewives. We were seeing some signs of increased production of smelt and bloater chubs and sculpins, and we'd seen an increase in round goby numbers.